To begin with, let's meet today's speaker. Representing RadiciGroup High Performance Polymers, Mr. Claudio Ghilardi is a computer-aided engineering analyst who's been working for RadiciGroup since 2015. He provides customers with support and consulting for design, manufacturing, and performance evaluation for components made with engineering polymers. So thank you for joining us, Claudio.
Thank you very much.
Right. So without further ado, I would like to give the space to Claudio to explain to us how RadiciGroup approaches metal replacement with their innovative materials and design solutions. So Claudio, the stage is yours.
Okay, thank you very much, Samir. I will start the introduction of my presentation. Today we will talk about the metal replacement and how it will take more and more importance in all the industrial sectors. Then we will show RadiciGroup solutions for these projects with innovative materials and a proper design approach. Here is the agenda of the presentation. First of all, I will introduce RadiciGroup High Performance Polymers, and it's present with thermoplastic materials on the main markets. Then we will have a look on the key concept of metal replacement and the macro trends, which are leading to a continuous increasing use of high-performance polymers for metal replacement projects. Then RadiciGroup material portfolio will be shown. In particular, we will presented some grades specifically developed for structural demanding application. After that, we will see the correct design approach with technopolymers, and then the CE tools available in RadiciGroup High Performance Polymers in order to perform a correct material selection and redesign of the parts. To close, we will see some interesting case histories where the metal replacement has been successful using our material and expertise. So, RadiciGroup is an Italian company specialized in the production of chemicals, high-performance polymers, and advanced textile solutions. RadiciGroup offers a wide range of products developed to meet the needs of specific application markets. The turnover of the group related to the year 2020 is about 1 billion euros, with 3,000 employees. We are present worldwide by industrial and sales network in Europe, Americas, and Asia. We, as RadiciGroup High Performance Polymers, can offer a complete range of materials, even special tailor-made products, thanks to our upstream integration of polyamide 6, polyamide 6,6, polyamide 610, polyamide 612, and compolymers. With people's expertise and qualified support, Radici offers continuous innovation, development, and sustainability along the entire production chain. As mentioned before, RadiciGroup High Performance Polymers, thanks to the upstream integration, has a wide range of polyamide-based products, and to support a complementarity in the material portfolio, RadiciGroup has also compounds based on the polyphthalamide, polyphenyl sulfide, and polyester. Confirming our commitment to sustainability, recycled materials with post-industrial and post-consumer origin are produced and offered to the customers. We are present with our material brands in various markets: automotive, electrical and electronic, and consumer and industrial goods. Our focus is on innovation and sustainability, and this leads us to the research for materials performance in different challenging fields. In metal replacement, where we can offer special ultraflow PA6 and PA66 with high glass content. These materials show high mechanical properties, and they are suitable for structural demanding applications. Long-chain polyamide, where we have materials partially bio-based with enhanced chemical resistance, and which are intended to use in contact with aggressive substances. We are focused also in high heat resistance formulation, aimed to extend the limits of the applications in terms of heat and temperature. And finally, facing the challenge of vehicle electrification, we are present with material specifically developed for e-mobility sector and its demanding requests. So, metal replacement is technological challenging, but what exactly it means and what are the advantages from its use? Let's see it together. The meaning of metal replacement is contained within the word itself. Is the substitution of one or more parts currently made in metal with a part having the same functionality, made with a different material, namely engineering plastics. Metal substitution with engineering polymers on demanding application has a successful long history, and it started more than 30 years ago. However, today it is an actual theme, and it's becoming more and more challenging field, but with some larger leeway regarding the use of it. Indeed, there are still great opportunities in all markets, where there are several components which are not yet being considered for metal replacement. The macro drivers for the usage of engineering polymers in innovative products are reduction of the production cost. As we will see, there are some benefits given by the reduction of the of some post-processing phases. For example, machining, painting, but not only. Indeed, also the investments are lower if compared with the production of metallic parts. Lower environmental impact of the products. Considering the life cycle assessment, a component made in plastic generally has a lower carbon footprint compared with the steel made one, thanks to the lower CO2 emission during the entire product life. Lightweighting, in particular for the automotive and transportation sector, where new regulations on CO2 emission limits leads to have a light vehicles in order to reduce for internal combustion engine the fuel consumption and consequently the emission of CO2. This concept can be also used for electric vehicles in order to increase the range extending. We talk about the advantages coming from the metal substitution. Now we will see them deeply. First of all, with the reduction, engineering polymers have a lower density compared to the aluminum or steel. So lighter material, lighter parts. We have a certain freedom in shape or design parts, using also complex geometry features. As we said previously, the metal substitution gives a good impact on the environmental sustainability. From the aesthetic point of view, parts made with engineering polymers has a very good aspect and can be produced in various colors without painting, since the granules of materials are dyed in mass. Last but not least, the use of engineering polymers allow a less cost of the part, thanks to the reduction of assembly and post-processing phases. But also benefits came from the higher productivity, lower cost of process technology, and longer tool life if compared with die casting and molding. Radici Group, as a material supplier, has in its material portfolio a wide range of engineering polymers that are specifically developed for metal replacement projects. Let's take a look. Our Radilon brand contains a series of various types of polyamides, starting from polyamide 6 and polyamide 6,6 up to the long chain polyamides, and then polyphthalamide. Radilon S URV 500W and S URV 600W are compounds based on the polyamide 6 with a high glass content and are suitable for products which require high productivity along with very high stiffness and high mechanical strength. Compounds based on polyamide 6,6 with 35 or 50% of glass fiber can be used for structural parts that require high stiffness and high mechanical resistance. These materials are suitable, for example, for parts like oil pumps, engine supports, and turbo air ducts. Based on polyamide 6,6 polymer, we have the HHR material family, which can be used in application where we have continuous using temperature with hot air up to 210 degrees. Radilon D and Radilon DT are products of the long chain polyamide family, respectively based on the polyamide 610 and polyamide 612. These grades show high chemical resistance and can be used, for example, in the automotive sector, such as fuel lines and pneumatic brake air lines. But this grade can find applications in particular in the water management and appliances sector, such as valve housing and water meters. Under the brand Radilon, we can also offer compounds based on polyphthalamide that show a superior hydrolysis and chemical resistance along with a high melting point. PPA materials are suitable for structural parts requiring high stiffness and mechanical resistance. Radistrong brand contains special polyamide 6,6 glass fiber reinforced grades, which show lower moisture sensitivity. These grades are suitable for structural parts requiring high mechanical properties and superior surface aspect. Radic is the brand of compounds based on PPS polymer, and these grades show balanced matching of superior chemical resistance, superior dimensional stability, and inherent flame retardancy property. Radiflam is our brand for compounds based on polyamide 6, polyamide 6,6, polyphthalamide, and polyester with flame retardant fillers, which are intended to use for parts in the electrical and electronic market, like terminal blocks or switch connectors. In the last period, since the growth of vehicles electrification, special grades are specifically developed to be used in the e-mobility sector. As for example, Radiflam ARV 250 HF, which is a PA66 25% of glass fiber, halogen and phosphorus free, which is suitable for parts requiring fire retardancy along with medium stiffness and good mechanical resistance. Typical application is for charger plug connectors and cell holder housing. After the material portfolio presentation, I will take a look on the design approach with engineering polymers, considering the peculiarities of these materials. First of all, it is good to resume the key concept of the metal replacement and reiterate that the replacement of metal with engineering plastics is done with a part that has the same functionality. It means that is not make the part in plastics, assuring the same property, because plastic is not metal. So we are committed to think considering how to take the advantage of plastic peculiarities. A correct approach to metal replacement must be taken into deep consideration from the very beginning stages. The functional requirements of the parts, including the implicit ones, and the way it interacts with other parts and the operating environment. The intrinsic properties of plastics, which compared to the metal are strongly different and must be taken into account where we are in the design phase. So it is necessary to have an overall view of all these aspects related to the project to pre-select the material and then to redesign the part. As is well known, reinforced plastic, if compared to metals, show fundamental differences in properties. As we can see from the HB chart, the stiffness of the plastic is 10 times lower than metals, but at the same time, the density can be 1.5 to 10 times lower. We also have a totally different mechanical behavior in temperature. Indeed, metals have an influence on the property only at a certain level of temperature, generally high. So the substitution implies a deep redesign of the part, which must be made for plastic according to its properties. We say that the metals are 5 to 20 times stiffer than reinforced plastics. As we can see from this table, the elastic modulus of the steel is quite higher than compared to the modulus of polyamide 6,6 with 50% of glass fiber. Because of this, a part in metal, if made in plastic with identical geometry, will likely result in being too much flexible and premature breaks may occur. In order to ensure the mechanical performance of the part, it is fundamental to increase the flexural and torsional stiffness, acting on these parameters. For example, increasing the thickness, increasing the material modulus by increasing the fiber content or using different type of reinforcement, or increasing the moment of inertia by the optimization of the section geometry. Here are some hints on how approach the design with engineering polymers. First, we take a look onto the part's thickness. Thickness should be high enough to ensure required stiffness and mechanical strength of the part, but also from the process point of view to ensure a proper resin flowability and cavity filling. At the same time, thickness should be low enough to ensure low shrinkage, good aesthetic, moderate cycle time, and minimum part weight and cost. As a general rule, thickness as low as possible, provided that the moldability and structural performances are guaranteed. Another important aspect is to design the part with thicknesses as uniform as possible throughout the part, in order to avoid the differential shrinkage during the molding process. Typically, the thickness of the plastic parts for structural application ranges from 1.5 to 6 millimeters. Ribs are used in order to increase the moment of inertia and thus the flexural stiffness in a specified direction. It's very interesting that by increasing the height of the section increases part stiffness with a third power factor. A properly designed rib pattern, as we can see from the pictures on the right, give an optimal reinforcement in many possible bending and twisting directions, to which the part can be submitted with only a minimal material increase. Geometry of the ribs has a crucial importance. Thin ribs is difficult to fill, and the risk of buckling and potential warpage are present. At the same time, thick ribs leads to sink marks, void, and unbalanced filling. Hence, the use of ribs using the general guidelines reported on the right picture in order to ensure the right part stiffness along with a good injection molding process of the parts. Another thing to avoid in the design with engineering polymers are strong geometry discontinuities or sharp edges. For reinforced plastics material, the geometry discontinuities cause differential shrinkage, warpage, and mold filling defects. And when the parts are subjected to a load, these sharp edges, particularly the internal ones, cause stresses concentration and then high risk of premature part breaking. So hence the use of fillets in order to avoid these geometric discontinuities. Okay, now we are going to have a look on the CAE tools available in RadiciGroup High Performance Polymers, which are aimed to support the customers for advanced metal replacement projects. First of all, what CAE means. CAE is the acronym of Computer-Aided Engineering and includes many software tools that support the engineers using the FEM, finite element method, to solve technical problems numerically in different fields: structural mechanics, electrodynamics, heat transfer, fluid dynamics, and so on. Metal replacement can require multiple steps of analysis and modification of design before reaching a confidence level to confirm its feasibility. RadiciGroup High Performance Polymers has a long history in metal replacement projects and can provide to the customer its expertise for these innovative projects through a free-of-charge service that includes process and structural simulation in order to perform a material and design assessment and therefore the part validation. Indeed, the RadiciGroup High Performance Polymers has internally a CAE department with different available software. In particular, we are able to perform process simulation in order to predict the behavior of the material during the injection molding and derived technologies. We are able, with structural simulation, both static and dynamic, to foresee the mechanical behavior of the parts made in thermoplastic material when are subjected to a design load. The last but not least main field is related to what we call as integrated approach. So an advanced method to take into account the process-induced microstructural properties like glass fiber orientation in a structural analysis. Here are reported some outputs coming from the injection process simulation, such as filling path of the cavity, cooling efficiency, welding lines location, and also the warpage after the molding. These results can help the engineers to predict the material behavior during the injection molding process, identifying possible design criticities of the part. In this slide, we can see various pictures coming from different types of structural analysis, such as static analysis on a 4-point bending test of a rivet beam, an impact analysis with a dart that hits an oil pan, model analysis of a cam cover, fatigue life evaluation of a bearing housing. So these outputs coming from this structural simulation can help the engineers and designer to assess the mechanical response of the parts, identifying weak points. Previously, we talked about the integrated approach, so an advanced type of simulation that takes into account the process-induced properties in the structural simulation. But why it has a fundamental importance for metal replacement projects which involve reinforced plastics. Generally, reinforced plastics show an anisotropic behavior given by the orientation of the fibers, which have a significant aspect ratio. So different orientation of the fiber respect to the direction of the load means different mechanical response of the material, as we can see from the right picture. In conclusion, we can say that the properties are a function of microstructure. But the orientation is a consequence of the phenomena which occur during the mold filling phase, thus are related to the part geometry and the transformation process. So the macrostructure is function of the process. The integrated approach to the structural analysis take into account the process-induced properties in the structural simulation, giving a higher accuracy and reliability in predicting elasticity and failure of the parts. Practically, outputs coming from the process simulation, such as fiber orientation, welding lines, residual stresses, and warpage, are mapped onto a structural model with a dedicated software. Then, structural simulation takes into account for each point of the part a specific mechanical response. This leads a more in-depth understanding of the material behavior and consequently to the reduction of over-engineering and the use of high safety factors. Another term which is often heard is eco-design. In practice, this means applying CE technologies to emphasize some good design and manufacturing practices, which have also positive effects, direct or indirect, in terms of sustainability and environment. Some of them you can see in this slide. Let me just mention design for this assembly, a topic which will become of more importance with the rising of the circular economy trends, facilitating dismantling and the recovery of end-of-life parts is fundamental in this sense. Reducing trial and error and physical prototyping is also an important thing. Also, optimizing a component's shape or exploring different alternative solutions can easily lead to discover the most virtuous way to perform a task. At this point, we have seen how to approach metal replacement from the material and design point of view. Now it's time to see some successful metal replacement projects where material and expertise of the Radici group were involved. For another customer which is operating in the automotive markets, we, as a Radici group, were involved in a metal replacement project of an oil circuit valve body and relative elbow, which were previously made with aluminum alloy. Our proposal was a polymer 6 with a 35% of glass fiber, material suitable for prolonged contact with hot air and motor oil, with an excellent fatigue resistance. The requirements of this application were quite demanding in terms of temperature exposure, as well as the fatigue and dynamic resistance of the material. We are able to provide the customer design support in order to assess and validate the parts through simulation tools. This project was successful, and now the parts are in serious production. For another automotive customer, we were involved in a metal replacement project of a battery support, which was previously made in steel. The material proposed for this application was a polyamide 6.6 with 50% of glass fiber. This grade has a superior thermal stabilization in order to meet the continuous temperature exposure of the part. And this grade shows very high mechanical properties. The requirements for this part were high stiffness and high strength, along with high creep and fatigue resistance. This is another successful metal replacement project on a diesel engine cam cover. The original material for this application was aluminum alloy, and RadiciGroup was able to support the customer, providing a dedicated CE service and a material solution. The proposal from our side was a polyamide 66 with 35% of glass fiber, with high stiffness and good mechanical resistance, and an excellent heat hedging properties retention. Requirements also in this case were high mechanical properties, fatigue, and creep resistance, as well as continuous use in temperature. For a customer operating in water management sector, we were involved for a metal replacement projects where a water meter diaphragm was redesigned and then validated through our CE tools in order to substitute the original material, cast iron, with a polyamide 612 with 30% of glass fiber. This material is suitable for parts requiring high stiffness and high mechanical strength, and shows excellent dimensional stability and chemical resistance. Also in this case, the requirements for this application were quite severe. In particular, the fatigue and creep resistance, which were assessed through a structural simulation. We are about to face the last slide of the presentation, and I want to remark on how RadiciGroup High Performance Polymers can be more than a material supplier, and really on a global team, including technical marketing, application development, and R&D to provide professional support throughout all project phases. Starting from the proposing and consulting in the early stages, then the material selection and the CE validation, up to prototyping and scale-up phases, with technical service support at molding trials and parts testing. So thank you very much for your kind attention. I leave my mail address in case you are interested to know more about RadiciGroup and its materials and services. Thank you.
Thank you, Claudio, for this impressive presentation. Really, really interesting information there and interesting material as well. We will now jump into Q&A. So thanks for everyone for your questions and for your participation. If you haven't already, check out our polls section. We have already shared a couple of polls for you to answer, and there's a new poll that should be also available for you to check out right now. Meanwhile, we will start addressing some of the questions that we have received. So here's an interesting question, Claudio. They asked which kind of polymers are the best suited solutions for metal replacement?
Okay, so the best suited polymer for metal replacement projects is a very variable thing, and depending on the condition in which the part is intended to work, and how it interacts with the surrounding environment. For example, in condition of use at high temperature, such as for application in the automotive under hood, the most widely used polymers are polyamide 6 and polyamide 66. This polymer then must be equipped with a very advanced thermal stabilization to ensure that they do not have a premature degradation, and they have a certain retention of mechanical properties. If the parts are then exposed to higher temperatures, moreover with aggressive substances, it is necessary to think about the use of PPA or PPS polymers. Another case, if the parts are in contact with aggressive solutions, but it works at a lower temperature, generally at 60 to 90 degrees, and it requires better dimensional stability, we can think to use polyamide 610 or polyamide 612. So generally, the requirements vary from application and application. For this reason, it's appropriate to draw them up and through a careful verification of technical requests, it is possible to identify the right polymer solution for the application. RadiciGroup is able to provide to the customer through the collection of the project objectives and challenges for the application, the right polymer solution in its material portfolio, and provide assistance from the beginning stages.
Great, great. All right, thank you for that. Here's another question from the recycling perspective. So, okay. Have post-industrial and post-consumer recycled materials ever been considered for such demanding applications?
Okay, the answer is yes, and it's becoming more and more popular and requested by the customers. We have in our material portfolio some materials which have a post-industrial origin. We are talking about grades made with recycled feedstock coming from an internal facility in our corporate. These materials, mostly based on polyamide 6 and polyamide 66, are already widely used for automotive components, and not only in this market. Some materials have found application in the metal substitution, where the technical requirements were very challenging, and despite their origin, they were successfully used for demanding parts, such as, for example, air ducts. For post-consumer grades, we are working on it, and we will get soon some projects where we can able to push these products with a very low environmental impact.
That's great. Really interesting, and thanks to everyone who's still putting your questions in. Here's another one for you, Claudio. This is related to the properties, the long-term properties of the material. So someone's asking, are long-term properties like fatigue and creep taken into account during the design phase with engineering plastics?
This is a very good question. Generally, these characterization and properties are taken into account for the design with metals. Even more reason, this type of test and the characterization must be performed on the polymeric materials, which, as we have seen previously, have a different mechanical properties compared to metals. This helps the engineers and the designers to design the part properly, not only from the static point of view, but considering also the long-term behavior of the material. These data are becoming more and more requested by the customer in order to push their design of the parts in order to obtain the maximum performances, even for a very long working time. RadiciGroup has, for some of its materials, mainly used in the metal replacement sector projects, fatigue and creep data that can be shared with the customer when a collaboration for for a strategic project is launched.
Mm-hmm. Great. Okay. Here's one more question that is quite interesting, and it's talking about simulation and testing. Like, how do you ensure the right correlation between simulation and part testing?
Okay, in order to have a good reliability on the simulation, the material must be characterized through various experimental tests aimed to obtain the information of the material behavior in various aspects. After that, these results will be elaborated and modeled following precise mathematical models. Then we create what we call as a material card. Before use this material card for simulations on parts of metal replacement projects, these material cards are first tested with various internal validation. I mean, inside our company, we are able to mold various demonstrator parts that are aimed to compare the physical test with the results obtained from the simulation. Just for explain it better, we have internally a mold that allow us to obtain a demonstrator ribbed beam. In the validation process, we compare the simulation outputs coming from the process simulation or the structural one with the outputs coming from the real injection molding or a structural test made on this component. If the comparison with the results obtained from the experimental test and the results obtained from the simulations are quite closer, the material card is validated. Otherwise, it must be revised in the mathematical model, and if necessary, the material will be possible retested. Only in this way we are able to provide reliable material cards which can be used for the innovative metal replacement projects and perform simulation with a high quality in terms of accuracy.
Mm-hmm. That's great. Unfortunately, we are coming towards the end of today's webinar. Amazing questions have been asked, really very, very good questions that we've seen in the questions section. But don't worry, you can still contact us and contact Claudio via email to get the answers to your questions. But as for now, Claudio, thank you very much for joining us. Thank you very much for this amazing presentation. And I hope everyone has enjoyed today's webinar. You can always get in touch with us and with Radici Group through the email with Claudio. And we wish you a pleasant day ahead. And that will be it. Thank you, Claudio, and good day.
Thank you. Have a nice day.
All right.
Bye.
All right. Bye-bye.